So the purpose of this video is to provide a more broad and more in-depth conceptual understanding of infinite limits. And to start off, let's look at a very familiar function, or at least it should be familiar, which is f of x equals x squared, a nice parabola right there. So let's review what a limit of a finite value is. Again, that's just maybe an integer or a decimal. In this case, I'm just going to use 1. So the limit as x approaches 1 of f of x. So when I say that the limit is of x approaching 1, I don't really care what f of 1 equals. In this case, it would be helpful to know what f of 1 is, given that it's a continuous function and it's not a rational function. There's no denominator. It's just a regular old function, basically. But in this case, let's remind ourselves of the definition of a limit, which is saying we're really caring about what it looks like to the right and then to the left of what happens at x equals 1. And if we go this way, you can see like it's slowly approaching this value right here. And then if we go this way, it's also slowly approaching that value. And that value is 1. So the limit of this function, as x approaches 1, would equal 1. But that kind of gets a little skewed when we talk about limits involving infinity. Because we're not asking for f of infinity, because that wouldn't exist. Instead, let's look at this a little bit differently. So the limit as x approaches infinity of f of x. So let's take this into a better understanding. Let's say that instead of inputting infinity, let's say we just input values larger and larger and larger and see what we get out from f of x. So if f of x, so f of 1 equals to 1, let's step it up a bit. F of 10 equals 100. F of 100 equals 10,000. And if we keep going, we're going to get larger and larger and larger and larger values infinitely. Because all we're doing is just squaring the number. We're just making it larger by multiplying it by itself. So as x takes on larger and larger and larger and larger values, it's just going to output larger and larger and larger values. As it goes this way, erase 2 there, as it goes continuously more and more, as the inputs get greater and greater and greater, so are the outputs. So the limit, as we take the limit of the x values and make them go to infinity, the y values will follow suit. They'll go to infinity too. So the limit as x approaches infinity of f of x, in this case, is infinity. Now what about if x was approaching negative infinity? Let me write that right there. The limit as x approaches negative infinity of f of x. Well, let's look here. As the negatives become smaller and smaller and smaller, in this case more and more to the left, more negative, as the negatives get more and more negatives this way, the outputs are going to get more and more positive. They're going to get greater and greater and greater. Because remember, it's just a reflection of what's on the right side. So as we get closer to negative infinity, the limit of the outputs, the limit of f of x, is going to equal infinity, just as the same as these two. For more technical purposes, we would say for these two that the limits don't exist because infinity isn't really a number. But for the sake of simplicity for now, for sort of understanding what's happening, I'm going to leave it as infinity, and hopefully that helps you a bit. So let's look at another example of a rational function. So now let's take a look at the graph of f of x equals 1 over x, which is a rational function having an x term in the denominator. So if we take a look at this, it's kind of odd. If you remember from Algebra 2 or for pre-calculus, you would know that this kind of function, where it's 1 over some x term, it has a horizontal asymptote, which means that there's a value, so on the y-axis, that the function will approach infinitely, but will never actually equal. It will never equal that number. So that sort of shifts our definition of limits a bit to the understanding that it's not so much what f of infinity is, it's what what x approaches to infinity is approaching. So let me show you for a second. So the limit of x approaches infinity of f of x, which is just this function right here. Well, let's take a look. So as we get larger and larger x values this way, it seems that the values of y are slowly approaching some horizontal asymptote. Let me draw that in green right here. So this horizontal asymptote. Sorry if that's a little bit difficult to see. So that horizontal asymptote right there, it's going to constantly be approaching that horizontal asymptote, which in this case is y, or not y, but I guess f of x equals 0. So it's going to be constantly approaching 0. So we're going to keep approaching 0 as we give it larger and larger values. And if we think about it, let's say that we do input, actually input larger and larger values. So we start with 10. Let's start with 10. So 1/10. Okay, let's input a larger number. 1/100th. Okay, a larger number. 1/1000th. And keep going, keep going, keep going. We're going to get smaller and smaller and smaller values. They're going to be infinitely approaching 0. They're never going to equal 0. They're only going to infinitely approach it. So when we say that the limit as x approaches infinity of f of x, it's going to approach 0 because it's going to constantly be approaching smaller and smaller values. It's going to have a horizontal asymptote at y equals 0. It's never going to equal 0, but it's going to get really, really close to 0, which is what this question is essentially asking. What happens as we take the limit as x approaches infinity? Well, as x gets larger and larger and larger, the f of x outputs get smaller and smaller and smaller and smaller, infinitely small, to the point where it's just 0. So in other words, this can be a little helpful later when you get to more complex limits involving infinity, where the limit as x approaches infinity, or the limit as x approaches negative infinity of 1 over x equals 0. Alright, that'll be a little bit helpful to know when we get to something called end behavior models, which is something we're going to be looking at next, and I'm going to be explaining why it makes sense and how can it help, relieve the stress of all this mess, all this graphical mess.